Hello, DAdapatil Rajale Arts, Science and Commerce College, Adinathnagar, Taluka Pathardi, District Ahmednagar. Department of Mathematics organizes the state level webinar on mathematical thinking, where this logic, computer programming, and the behavior will be discussed. So, on the behalf of DAdapatil Rajale Arts, Science and Commerce College, IQC and Department of Mathematics, I, Dr. Atul Chorpagar, Department of Zoology, welcome you all. Dignitaries present on the screen and off the screen. So, in the today's state level webinar, in the mathematical thinking, first of all, I request today's chairperson, Dr. Janardhan Yan Nehul, Department of Botany and faculty in charge, Science, to give the introductory speech for this state level webinar. I request Dr. J. Nehul sir.
Very warm greetings and good morning to all of you. The principal of the college, Dr. J.Temkar sir, today's resource person, Professor Lagad sir, Head Department of Mathematics, Ahmednagar College, Ahmednagar, Head of the Department of Mathematics, who has organized this one-day online state level webinar on mathematical thinking, Dr. D.N. Kandekar, Head Department of Botany, all my faculty members, and all the participants. On behalf of DAdapatil Rajale Art, Science and Commerce College, I first welcome all of you. DAdapatil Rajale Art, Science and Commerce College, Adinathnagar, Taluka Pathardi District, Ahmednagar, Maharashtra, has been established by Honorable late DAdapatil Rajale in 1991. The college is located in rural area. Majority of the population of the given region works as a sugarcane cutters. The vision of the college is to impart knowledge and skills in rural youth for creating strong human resource needed in nation building. The college is dedicated to provide education for all, with its mission to bring the deprived section of rural society like women and socially and economically weaker sections into mainstream of higher education. To accomplish its mission, the stakeholders of the college have taken great efforts right from the campus development to student satisfaction. The college provides learner-centric atmosphere with the help of ICT-based resources, then well-equipped library and laboratories, gymnasium, indoor stadium, and competitive examination guidance center. NSS unit of the college is involved in various activities and outreach programs. The college organizes national, state level, and local level seminars and workshops. The college conducts 3 days lecture series from 20th August to 22nd August on the occasion of birth anniversary of Honorable late DAdapatil Rajale alias Bhau. The internal quality assurance cell of the college has been committed to develop and implement a system for conscious, consistent and catalytic improvement in the performance, leading it to the excellent learning center of rural area. The college has offered various courses for students. It has offered 5 academic programs in the science stream and post-graduation in analytical and inorganic chemistry, and 6 programs in art stream as well as commerce. A separate computer science and commerce program has been offered. Today, the Department of Mathematics has organized this one-day state level webinar on mathematical thinking. The Department of Mathematics is one of the leading departments in the college. The faculty is well qualified with SET, NET and PhD qualification. The department organizes various curricular and co-curricular activities for the overall development of the college and the students. Today's webinar on mathematical thinking. Mathematical thinking is quite different than doing maths. Thinking mathematically and logically are similar. Mathematical thinking also improves your mind in terms of logical thinking. And logical thinking in turn helps us to excel in other subjects as well. Logical thinking makes us a better problem solver, which can come handy in even outside of academics and mathematics also. So again, I welcome all of you, all the participants, resource person, and again I welcome you, and I am quite sure that the today's webinar will be helpful for the students as well as for the faculty. Again, I welcome all of you and thank you.
Thank you, J. sir, for such wonderful words for us, and wishes, very best wishes for the today's state level webinar on mathematical thinking. Friends, now I request Dr. Dnyandeo Kandekar, Head Department of Mathematics, to introduce our today's resource person, Professor Ashok Lagad, sir.
Thank you, sir. Now, I will introduce the today's resource person, Professor Ashok Lagad. Professor Lagad, sir, has done his graduation from Ferguson College, post-graduation from Pune University, and he qualified CSR UGC JRF in 1987, and he had done MPhil at University of Pune. Now he has tremendous experience regarding in college committees as well as in extracurricular activities. Now he is working as associate professor at Department of Mathematics, Ahmednagar College, Ahmednagar, and now he is working as a college exam officer. Now he has skills regarding computer softwares, namely MATLAB, Scilab, LaTeX, and text. Also, he is well-known person in computer languages C, C++, and Pascal. Also, he have additional computer knowledge regarding data structure and decision analysis. Also having knowledge about operating system, Unix, Linux, and MS Windows. Now, he has participated in 4 refresher courses, and he also participated in syllabus restructuring in various classes at Pune University. Now, he is having tremendous record in resource persons. Now, we are having only biodata up to March 2017. Therefore, we are giving only at least number of numbers here. Now, he has worked as a resource person in 13 refresher courses, then 3 winter and summer schools. Then he has guided participants in 3 Inspire programs. Also, he has worked as resource person in international level, national level, state level, and university level in seminars, workshops, and conferences in 32 seminars. Also, he has worked as faculty resource person as a faculty development programs. That is namely 3 faculty development programs. And now, he also has outstanding work in 6 paid tasks at Ahmednagar College. and he has judged the model and poster representation competition at Dr. Babasaheb Ambedkar Marathwada University, and also he had delivered lectures all over Maharashtra in state level as well as university or national level conferences. Most of the lectures are delivered on C, C++, data structure, and LaTeX. Now, finally, it is hard to recognize a person by appearance. He is very genius, all-rounder person. Thank you, sir. Thank you, sir.
Uh, Thank you, Dr. D.N. Kandekar, sir, for such a brief introduction about today's resource person, Professor Lagad, sir. Now I request Professor Ashok Lagad, sir, Head Department of Mathematics, Ahmednagar College, Ahmednagar, to give a lecture on mathematical thinking. I request Professor Ashok Lagad, sir.
सर तुमचा आवाज येत नाही क्लिअर.
आवाज येतो आता?
ओके.
Thank you, sir. Let me thank Dr. Dnyandeo, Kandekar, Head Department of Mathematics, DAdapatil Shri College, and organizing committee for organizing this webinar and for this invitation. Without wasting the time, let me start here the direct lecture. So, are you seeing my screen clear?
Yes, sir.
Is my screen is visible to all?
Yeah. Yes, sir.
Yes, sir. Okay, this is a not a pure slideshow lecture. This is an interactive lecture, so all participants have to involve in this webinar. Okay, so whenever you know the answer, you please reply immediately. So here is the first problem that we discuss, Josephus problem. Josephus was a king, but he was not famous because of the king, but he was famous because he was very talented in mathematics. Here is the Josephus problem. This problem is really very old. Josephus stated in 1st century. Actually, this is a game, something like a music chair. So statement of the problem is something like this, that imagine young people standing in circle, each of them is numbered a clockwise direction or anti-clockwise from 1 to n. The game is to remove a person one at a time. You start from a person and count in direction in which people are numbered and remove every second person. That is, skip one and remove the next, skip next and remove the again. The game then continues with n people and you start counting to 2 from the person next to removed one. The one who remains in the end is declared the winner, or we may call it as a safe position. The goal of the game is to find out who will be the last remaining player. Let me give here one demo. Suppose there are 12 people standing in a circle and we start from the first person and remove the every alternate person. The persons removed, you remove the alternate person and continue this game as long as the number of people are more than 1. So skip first and remove second. Now skip third and remove 4. Skip 5 and remove 6. Now skip 7 and remove 8. Skip 9 and remove 10. Now skip 11 and remove 12. Now continue this, that skip 1 and remove 3. Now skip 5 and remove 7. Similarly, we skip 9 and remove 11. And next we skip 1 and remove 5. And last that we skip 9 and remove 1. So 9 is a safe position for you. Now, what is my problem that how we find out the general formula for n people? For example, if I ask that if there are 100 people or persons, which place is the safe for you? So if number of people are 12, then 9 is a safe place. What is the relation between 12 and 9? That we have to find. Let us see one more demo. Suppose number of people are 15. And now continue just like the previous, that skip the first and remove second, skip 3 and remove 4, skip 5 and remove 6, skip 7 and remove 8, skip 9 and remove 10, skip 11 and remove 12, skip 13 and remove 14, skip 15 and remove 1, or skip 3 and remove 5, skip 7 and remove 9, skip 11 and remove 13, skip 15 and remove 3. Next we skip 7 and remove 11. And finally we skip 15 and remove 7. So 15 is safe place for you. So how we think mathematically now? How we solve this problem? How we find out the formula for n? Or in short, if I ask 100 people are there, then which place is the safe for you? Anybody? Idea? Yes, participants can reply. Hello. Can anybody reply that how we find out if the number of people are 100, then what is the safe place for you? So how we solve such a types of problem? And if you don't have any mathematical background, that first thing, what mathematics we use here? When there is such a confusion, then what is the best method that we play this game for sufficiently small numbers and collect your empirical data? And from that data, we try to find out the answer or guess at least the pattern. And from that pattern, we make your own theorem, make your own statements, and try to prove your own statements. So let us see here. We prepare here one simple table. So number of people are, suppose 1, then clearly that 1 is a winner. If number of people are 2, then we skip the first and remove the second. So again, 1 is the best place for you. If number of people are 3, then we skip first and remove second, and skip 3 and remove 1. So 3 is a safe place for you. Can anybody answer that if number of people are 4, then which place is the safe? You can play. Take pen and paper, pencil and paper. Hello, Kandekar sir. Hello.
Ha, sir.
पार्टिसिपंटला माईक अलाउड आहे ना?
नाही नाही.
अच्छा 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 अच्छा. त्यांना अलाउ करा ना सर.
युट्यूब लाईव्ह आहे सर ते, त्याच्यामुळे नाही ना. कमेंट्स मध्ये आले तर मी डिस्प्ले करतो तुम्हाला काही.
अच्छा, इकडे नाही आले कुणीच का आपल्या याच्यावर?
नाही नाही, युट्यूबला लाईव्ह डायरेक्ट.
अच्छा, डायरेक्ट लाईव्ह लेक्चर. मला त्यांच्याशी इंटरॅक्शन पाहिजे होतं असं. ओके, ठीक आहे. And we observe that for 4, that winner is a 1, then play for 5, the winner is a 3, for 6, winner is a 5, for 7, winner is a 7, for 8, winner is a 1, for 9, winner is a 3, for 10, winner is a 5. If number of people are 11, then winner is a 7, for 12, just we observe that the winner is a 9. For 13, winner is a 11. For 14, winner is a 13. And for 15, we already have played this game. So answer is a 15. For 16, answer is 1. Now, from these 16 observations, we can observe the following: that answer is always odd. Of course, even positions are very bad because we are starting from the first and removing every alternate person. So in first round, all even positions are removed. So at least our guess must be that answer is always odd. Now, what is the next observation? That when number is answer is a 1 for 1, then for 2 is also 1, for 4 is 1, for 8 is 1, and for 16 it is a 1. And what is the speciality about these numbers 1, 2, 4, 8, and 16 is all these are the powers of 2. Now, question naturally arises, is it true in general? If number is a power of 2, then 1 is always a winner. The answer is yes, because it is fairly simple when we start from the 1. And because n is a power of 2, which is an even, so at first round we remove exactly 50% people and 50% people are left. So 2 raised to n divided by 2, now how many people are left are 2 raised to n minus 1, and we will reach again on the 1. Then again in second round we remove the 50% people and 50% people are left. So the next time 2 raised to n minus 2 people will left. And continue in this way. Finally, there are only the 2 people, and we know the answer for 2 is a 1. Now, what about the other numbers? For other number, we always find out the next odd number. So, for example, for 4 answer is a 1, then what is the next odd number is a 3. Then next odd number is a 5. Then next odd number is a 7. Next odd number is really 9, but because only there are 8 people that in circle after 8, who is a 9th position is a 1. So cycle will complete and we restart from the 1. And continue like this, that 1, then next 3, then 5, 7, 9, 11, 13, 15, and next is the 17. So cycle will complete and we restart from the 1. And let us see a few more observations. 1, now for 18, answer is a 5. For 19, answer is a 7. For 20, answer is a 9. For 21, next odd number is a 11. Then for 22, next odd number is a 13. For 23, next odd number is a 15. For 24, next odd number is a 17. For 25, answer is a 19. Then for 26, it is a 21. For 27, it is a 23. For 28, it is a 25. For 29, it is a 27. For 30, answer is a 29. For 31, answer is a 31. And for 32, answer is 1. So our guess is correct, because after 31, next odd number is a 33. But only there are the 32 people. So in circle after 32, the 33rd position is a 1. So when number is a power of 2, answer is a 1, and if number is not a power of 2, then we find out the next odd number. Now, if we do such a serial numbers, then I can find out the answer for 33. It is a 3, then 34, it is a next odd number, and continue. But if I ask that, what is the answer if number of people are 1,000? Now, playing this serially, then that is we start from the 1 and go up to the counting the 1,000. Counting all these numbers is really the expensive. I want the quick method. Or if I just we think that we sit on the table and just write one program on computer that if number of people are n, then how we find out the best position for you, or what is the position of the winner. The trick is a simple. We have a hint that answer is a 1 when number is a power of 2. And now what is the next question, that when number is not a power of 2, then we find out the position of that number after the nearest power of 2. After nearest power of 2. What I mean, suppose we have to find out direct answer for say 25. Now, before 25, which number is a power of 2 and very close to 25 is 16. And now we find out the position of the 25 after 16. Now 17, 18, 19, 20, these are the 4, and next 21, 22, 23, 24 are 4 and 25. So 25 appears at 9th position after 16. But instead of counting this, actually, we can find the relative position of a one number with respect to another number by subtracting the one number from another. So we can quickly find out this as a 25 minus 16 is nothing but the 9. And we all are from mathematics, so we know that kth odd number is a 2k plus 1. So what is a 9th odd number is nothing but the 2 into 9 plus 1. That is a 19. So this is really the simple trick that how we find out now the answer for 100. So less than 100 and very close to 100, which is a power of 2, is a 64. What is a 100 minus 64 is a 36, and what is the 36th odd number is a 36 into 2 plus 1, that is a 73. So here is a general formula that the position of the winner is we subtract largest power of 2 from n, then double that number and add 1 in it. Here we choose m is the largest positive integer such that 2 raised to m is less than n. Of course, when number is sufficiently large, that finding such a m quickly is like difficult. So here is an alternate formula that we subtract the n minus 2 raised to log of n, where log is taken to the base 2, and add 1 because that is the choice of the m. Well, because we are from mathematics, so we know what are the powers of 2 and how to find out the big powers of the 2. But how we explain this problem to the ordinary person? Or does there exist some more quick method, or what is a closed form to write suppose we have to write this program on computer. Now on computer, we subtracting the largest power of 2, finding the number power of 2 which is less than n and close to n is really difficult. That there is a we have to play it by trial and error or serially. Is the number is less than 2, is number is less than is greater than 4, is greater than 16, greater than 18, like this. So what I want this problem to write the program is just one line long. Is it possible to write this program using only one line? The answer is yes. So here is an alternate trick that for 25, first we convert the 25 in binary. So what is 25 divided by 2, remainder is 1 and quotient is 12. Now again divided by 12 by 2, so quotient is 6 and remainder is 0. For again, we divide by 2 for 6 and remainder is a 0 and quotient is a 3 and continue in this way. So 3 divided by 2, remainder is a 1 and quotient is a 1, and finally we divide by 2 to 1, so quotient is a 0 and remainder is 1. So what is the binary form of 25 is 1 1 0 0 and 1. Now we have a binary representation of 25, but in actual programming we know there is no need to convert the number in binary because inside the machine numbers are always stored in binary. Now how we convert this number into decimal? That is 1 into 2 raised to 4 plus 1 into 2 raised to 3 plus 0 into 2 raised to 0, then 0 into 2 raised to 1 plus 1 into 2 raised to 0. That is, we start from the right hand side. So position of the 1 is a unit place, then next is a 2th place, then next is a 4th place, then next is a 8th place, and next is a 16th place. Just like in decimal number system, when base is a 10, we say that last position, last digit, position of the last digit is a unit, then 10th position, then 10 square position, that is 100, then 10 cube position, that is 1000, and so on. Now, what was the first difficulty? That how we find out the largest number, which is power of 2 and close to the given number. The trick is a fairly simple. Convert the given number in binary and look at the position of the first one, that is a 2 raised to 4. And subtracting that number is a fairly simple. So we don't need, there is no need of actually doing the subtraction. We simply remove the first term of the binary number, that is a 2 raised to 4. So after removing the largest power of 2, the effect is the same, that we are subtracting the largest power of 2 from it. And what number is left? That 1 into 2 raised to 3, 0 into 2 raised to 2, plus 0 into 2 raised to 1, and last 1 into 2 raised to 0. So what is the new number is 1001. So let us see here the trick. First, we convert the number in 25 in binary, then remove the first leading one. So removing the first leading one from any binary number is same as subtracting largest power of 2 from it. So that is the first trick. Now, what is the second trick? That we have to double this number and add a 1 in it. We know that when we put 0 at the end of any number, then effect is multiply by base. So in decimal number system, for example, if the number is a 345, then if I put the 345 0, then effect which is same as a multiply by 10. Substituting 2 zeros at the end is the same as a multiplying by 10 raised to 10 square. What is the general rule? If n is any number in base b or radix b, then if we put 0 at the end of the number, the effect is multiply by base b. So same is true in the binary. If I add the 0 at the end of this number, then the number become double. So that is called a shift operation. That is a shifted by left on one position. So what is the new number is 10010. So finding the answer is really simple now. When the number is in binary, no need of subtraction. Removing largest power of the 2 from given number is equivalent. We remove the leading one. Doubling number doesn't require any multiplication. We shift only the number to left hand side by one position. And adding 1 is fairly simple, that only we replace the last 0 by 1. And check, this is your answer, that is the 19. We already have observed this in the table. So there are 3 steps. So convert the number in binary and remove the leading one. Then removing the leading one is equivalent, that we are subtracting the largest power of 2 from it. Shift the number to left, which is equivalent, that you are doubling the number. and adding 1 is simply remove the first leading one. Actually, these three steps we can convert into the only one step, that what is the binary representation of one स्क्रीन दिसते ना सर? कारण लाईट गेली तर. The screen is visible?
Yes, sir. Yes, sir.
Okay, thank you, sir. So these three steps we can convert it into the single step, removing leading one, then adding 0 at the end, and then replacing that 0 is a 1. That is same as saying that in the binary representation of a 25, 1, 1, 0, 0, 1, we take the first one and put it at the end, and new number become the 1, 0, 0, 1, 1. This is called cyclic shift. So answer is really, the problem was really the complicated initially, but now using the binary method, the problem is very simple. So how we find out quickly the answer, convert the number in binary and put the leading one at the end. That's it. Hope you all enjoyed this problem. Now another question arises that why we are removing the alternate person, that we skip the first, then remove second, then skip the third and skip fourth. What happens if I remove every third person, say skip first and second and remove third, skip fourth and fifth person and remove the sixth and continue? Or we can generalize this problem as following, that what is the generalization of this problem, that how we define a function j, n, k, and what is the rule that we remove every kth person. So we solve the problem for k is equal to 2, and what is the answer for jn2 is nothing but the 2 times n minus 2 raised to m plus 1. Now, does question naturally arise, and does there exist a general formula for j and k? Actually, for k is equal to 3, much work has been done, but the general problem is open, that there is no concrete formula for j and k. That is a compact formula. However, there is a recurrence relation that we can find out the answer recursively for any k, and what is the recurrence relation, that f of nk is same as the f of n minus 1 comma k, and add the k minus 1 modulo n plus 1, and if n is equal to 1, then answer is 1. That is subsidiary condition. This recurrence relation is ideal, that is same as saying that we remove the kth person, and now how many people are left? N minus 1. So replay the game by assuming n minus 1 people are there, and shift the position of that answer by k minus 1 positions, so that you will get the original answer. So participant must try for this problem in general, or waste some, at least play with some values and try to find out what are the patterns for k is equal to 3, for k is equal to 4. At least find out the prepare the table just like for the k is equal to 2 up to some number, say 50, and try to guess. And that really the guessing the answer for when k is greater than 3 is very difficult. Well, let me discuss here the second problem. This is an interesting problem given in the one of the examination. There is an interaction between the census taker and a woman. The census taker asks the woman that how old are you? How old are your 3 daughters? The woman says the product of their ages is 36, and the sum of their ages is our house number. A census taker, after some figuring, because census taker can see what is the house number, and he replied that this is not enough information. So woman said, oh, my eldest daughter has red hair. And immediately the census taker say, thanks, now I know the ages. Now what is the question? How old are the three girls? So this is a logical thinking. That is a in conversation that when census taker says that the given information is not enough, why he says something like that? And that is a clue. So what is the idea? We factorize first 36 into the triplets. So how many possibilities are there? So first possibility is a 1 into 1 into 36. Their product is a 36. The next possibility is a 1 to 18. That is again product is a 36. There is one more possibility, that is a 1 3 12, because 12 threes are 36 and into 1 is a 36. The next possibility is a 1 4 9. There is one more possibility, that 2 2 9, that we split the 4 as a 2 2. We split the 3 9 into the 3 into 2, and what is the next possibility is a 1 6 6. And now again split the 6 into the 2 into 3. So there is a one more, that is a 2 3 6. And naturally in 149 we split the 9 as a 3 into 3 and skip the 4 as it is. So one more possibility is there, that is a 3 3 4. Now if I say that ages of the three daughter are is product of the three ages is 36, then there are so many possibilities. There are 8 possibilities. So additional hint was given that the sum of their ages is a house number, and that is a clue. Let us see, or let us find out the sum in each case. So in first, that sum is a 38. Then next sum is a 21. Then next sum is a 16. Then next sum is a 14. Then next sum is a 13. Then next sum is a 13. Next sum is a 11, and next sum is a 10. Now imagine that house number is a 38. If house number is a 38, then there is a unique combination, that 1 1 36, whose product is a 36 and sum is a 38. The same is true for the 21, for 16, for 14, for 11, and for 10. But census taker is saying, he was confused and saying that given information is not complete. What does it mean that house number was a 13? And there are the two answers. And that is the reason why census taker said that given information is not complete. So house number was a 13. Otherwise, in other cases, no additional information is required. Only these two conditions are enough, that product is a 36 and sum is unique. The corresponding ages are interesting. There is a one triplet is a 2 to 9 and other is a 1 6 6. There is a one pair is a twin pair. Now what we want, that the census taker only want a hint that which child is a single, whether the elder or younger, or eldest or youngest. And because the woman said, my eldest daughter has red eyes, what does it mean that the eldest daughter is a single and the other two is a twin pair? So what is the correct answer is a 2 2 9. So we have to think in some problems something like this, that is a logical, or that is a clue actually from the why some census taker is saying something like this. Of course, teaching such a thing to the computer is really difficult. After all, computer is a machine, cannot think like a machine, a human. Now, let us take the one more problem, that is one more application of the binary number, how we find out the a raised to n, where n is a non-negative integer, and what is the fastest method for this? There are plenty of applications where people want higher powers of the any number. Say, for example, how we find out the 100th power of a given number. So what is the least number of multiplications? And in worst case, if the a is not a number, but if a is some other object like a polynomial or say matrix, then things are again more difficult. For example, to find out the product of the two n by n matrices, we require n cube multiplications. So if I consider the 100 by 100 matrix, and suppose you have to find out the 101th power of it, then for one matrix multiplication, we require the 100 cube, that is 1 followed by 6 zeros, that is a 10 raised to 6 multiplications, and multiply by 100. So we'll require the 10 raised to 8 multiplications. That is really the very huge number, and even computer will take too much time. So what is the formal definition that we learn in the high school is a raised to n is a into a n times. So how many multiplications are involved? N minus 1. But one is clear that if you want to find out the a raised to 4, then we are not finding a in a square, a into a 4 times. What is the quick answer? That from a we can easily calculate a square and again take the square of the a square, that you will get a raised to 4 at the cost of only 2 multiplications. Similarly, if I ask what is how many multiplications are necessary to find out the a raised to 16, then we use the squaring method, that is take a square, a square, then again take the square of the square, that is you will get a raised to 4, then take square of a raised to 4, you will get a raised to 8, and take square of the a raised to 8, you will get a raised to 16. So only 4 multiplications are enough and not 15 multiplications are required to find out the a raised to 16. But what about the other numbers? If number is not a power of 2, say 25, take one concrete example. What is the minimum number of multiplications for a raised to 25? The trick is simple, that the same trick I am using, what is called a squaring method. First, we find out the powers of the a as following, that a, then find out the a square, then find out a raised to 4 and a raised to 8 and a raised to 16, and next power is not required because it is greater than 25. So far, how many multiplications I have used? 4 to find out the a square, and from a square to a raised to 4 require one more multiplication, and from a raised to 4 to a raised to 8 need one more multiplication, and next a raised to 16 require one more multiplication. So far I have used 4 multiplications, and from these 4 multiplications we question naturally arises that which terms we involve in the final product. Of course, this is a simple, that if I take the a, then a raised to 8 and a raised to 16, then their product is nothing but the a raised to 25. So initially I use the 4 multiplications, and then we take the product of the a raised to 8 and a raised to 16, that requires again the 2 additional multiplications. So what is the total number of multiplications is the first 4, and these 2 are the 6. So only 6 multiplications are enough to find out the 25th power and not 24 multiplications. But when the number is very big, and when we have a big list, that a square, a raised to 4, a raised to 8, a raised to 16, then next power is 32, 64, 128, 256, 512, 1024, and so on. Then which terms you take in the final multiplication to achieve the n? that we use the same trick that we know that the 25 binary number is a 11001. We already observed this in the Josephus problem. And observe that we start from the right hand side to left hand side. So what is the unit place is a 1. So we take the first term, that is a A. Next digit is a 0. 0 means don't include that term, that is a don't include A square. Next is again a 0, so don't include A raised to 4. The next is a 1, so include A raised to 8. And finally, there is a 1, so include A raised to 16. So what is the total number of multiplications? So multiplication is a into A raised to 8 into A raised to 16, and that is nothing but the A raised to 25. So initially I used the 4 multiplications, and now these are the 2, so the 6 multiplications are enough for this. This is very famous method, also called a squaring method. Now you may raise one question that, is this method is the fastest method among all? Of course, don't say that use the logarithm that n times log of a, and that requires only one multiplication. Unfortunately, this is the slowest method because finding the log requires we evaluate the long series inside the machine. So that take the too many additions and too many multiplications. So logarithm is not a correct method. I have to use the straightforward multiplication. The answer is, this is not the fastest method. Let us consider here the 27. Now we know that a raised to 27 can be expressed as a raised to 3 raised to 3. Right? And we can calculate a cube using only 2 multiplications. That is, from a we find out a square, and take the product of a and a square, you will get a cube. So finding the cube of any number always require 2 multiplications. So for a raised to 3, we require 2 multiplications. Then again we have to find out the third power, so need 2 multiplications, and again third power, so require 2 more. So total number of multiplications are 6. As this take this as exercise for the participant, that we use this binary method, and it is not difficult to prove that number of multiplications by this method, that you will require here the, let us see here how many terms we have to take. So a square, then a raised to 4, a raised to 8, and a raised to 16, and how we obtain the 27 from it. So we take the 16th power, then we take the 2 also, so you will get the a raised to 22. In 22 we add 5, so we require the a and a raised to 4. So a raised to 4, a raised to 8, and a raised to 16, that multiplication is a raised to 27. So how many products are required by a binary method? So I initially use the 4 multiplications, and later on I require the a into a raised to 4, 1 multiplication, a raised to 4 to a raised to 8, 1 more multiplication, and a raised to 8 to a raised to 16. So total number of multiplications are 7. So using binary method, we need 7 multiplication using another trick, a raised to 3 and raised to 3 and again raised to 3. That is also same as a raised to 27, need only 6 multiplications. Okay. But this is not true always. Actually, this is true only for few numbers, that smallest integer where the number of multiplications need less than the squaring method is a 15. We can check that a raised to 15 can be calculated as a raised to 3 raised to 5, and a raised to 3 need only 2 multiplications, and a raised to 4 we find out the a square, a raised to 4, and then take the product of a and a raised to 4. So 3 multiplications, so 3 plus 2, only 5 multiplications. But using the binary method, the squaring method, we need 6 multiplications. So there is always a difference of the 1. Now, what is the main problem? That for which numbers that there is a difference or number of multiplications are less? The answer is not known. Is an open problem. So using computer program, that some finite numbers has been calculated that for some numbers that number of multiplication may reduce only by 1, and that difference is also not more than 1. But what is the general formula for n, that which n if we use some different method, then number of multiplications reduces to 1 is unknown. So this is another trick, that how we use the binary numbers to find out the past powers of any number. Please remember, if the number is a very huge, then for example, on today's machine, that what is the maximum size of the integer is on 64-bit machine, its size is 64-bit. So what is the largest, how many multiplications we need? 64. That is a time complexity of finding the power of a raised to n is a log of n, where n is taken to the base 2. Okay. You take this exercise and that find out some numbers where the number of multiplications are really less than the squaring method. And I already have given the two numbers. First number is a 15 and next is a 27, and you try for the next numbers, that for what numbers that we have another tricks. And here's a final puzzle, that imagine that there are the 10 machines in factory, each produces coin weighing 10 grams each. One day the factory owner comes to know that one of the machine is not functioning properly and produces coins weighing 9 or 11 grams. That is, the weight is either 1 gram less or 1 gram extra. And what is the question that you have to find out now? Fault in the machine. You only have a weight machine and you can use it only once. So how we tackle this problem? That we have to use the machine only, balance only one time. There are 10 machines, so imagine that there are 10 bags full of coins, and exactly one bag contain 40 coins. That is, their weight is either 1 gram more or 1 gram less. We have to use balance only once, and we have to find out which bag contain all 40 coins. Now what we do here for this problem, I'm not going in the detail because this is simple. We label the bags as a B1, B2, B3 up to B10 and collect the coins from the first bag 1, then from second bag 2 coins, then from third bag 3 coins, and from 10th bag 10 coins. Now what is the total number of coins? Is a 1 plus 2 plus 3 up to 10. So there are 55 coins. And what is the weight? If each coin is a 10 gram, then weight is a 550. But one bag contain the 40 coin. Suppose, for example, the third bag contain the 40 coin. Then how many coins we have taken from the bag 3? 3 coins. So weight must be either less than 3 or greater than 3. That is either 553 or 547. Similarly, if the bag number 9 contains 40 coins, then the weight will reduce or increase by 9 in 550. So we can use such a trick for this. Okay, we stop here. That hope you enjoyed the lecture, and if you have any queries, then you can please share with me. Thank you, sir.
Thank you, Professor Ashok Lagad, sir, for such a wonderful lecture and enlightening for us in the some mathematical, logical, computer programming and behavior of mathematics in a non-mathematical person also. So is a very good lecture that non-mathematical person can understand also the various tricks and what we can say the behavior of the mathematics in the life science also. So I request from the audience, if any query or any questions you have, you can ask on the chat box, or you can ask whatever in the share link also. So any question from the audience? So I request Pansari sir, if any questions on the chat box, uh, you can share to the sir. Professor Pansari sir. Yes. Any query or any questions?
No, sir.
Okay. Okay. Thank you very much, sir, Professor Ashok Lagad sir, for a wonderful lecture. Uh, Now I request Professor Sanjay Maske sir for giving the vote of thanks.
श्री श्री दादापाटील राजळे शिक्षण संस्थास दादापाटील राजळे आर्ट्स सायन्स अँड कॉमर्स कॉलेज आदिनाथनगर तालुका पाथर्डी डिस्ट्रिक्ट अहमदनगर डिपार्टमेंट ऑफ मैथमेटिक्स स्टेट लेवल वेबिनार मैथमेटिकल थिंकिंग लॉजिक computer programming and behavior of mathematics. I express hearty gratitude to Honorable Appa Sahib Rajale, alias Kaka. I express hearty gratitude to Honorable MLA Munikata Rajale. I express hearty gratitude to Jilla Parishad member Honorable Rajdhar Rajale. I express heartily gratitude to Honorable Guide Honorable Shivaji Rao Rajale. I express hearty gratitude to Secretary Shri J.R. Pawar. I express hearty gratitude to Principal Dr. J.Temkar. I express hearty gratitude to today's resource person, Professor Ashok Lagad, Head of Department of Mathematics, Ahmednagar College, Ahmednagar. I express hearty gratitude to Office Superintendent Shri Vikram Rao Rajale. I express hearty gratitude to all heads of departments DAdapatil Rajale College. I express hearty gratitude to supporting staff Professor Chandrakant Pansare, Professor Dr. J. Nehul, Professor Dr. Atul Chorbagar sir, Professor Dr. Kandekar, Mr. Ravindra Falke, and all teaching and non-teaching staff. I express hearty gratitude to all participants, teachers, and students. By prior permission of chairperson, program is over. Thank you.